Hello and welcome to Mathematics Optional Decoded. I am Maheep and we are doing a very important sequence, that is Math Optional Decoded. What are the myths and lot of misconceptions about math? And this is the question before you. The question is the math syllabus too vast? True or false? Well, the math syllabus appears very vast, humongous, but it is not so. There is a linkage between a lot of modules. Okay, so there is a linkage between calculus and real analysis, lot of topics like differentiation and continuity in one and more variable, then maxima, minima, and after that you have definite integral or Riemann integral, volume integration, so on and so forth. So geometry is also linked to vector, and this geometry is also linked to partial differential equation. So at first place the syllabus seems very large, but they are very much interlinked, they are very much intertwined with one another. And if a person is very much interested, if he has a flair for mathematics, he will not find it very difficult, because at the end of the day you are playing with either the pure maths or the applied maths majorly. Like you are playing with vectors, you are playing with differentiation, you are playing with integration, you are playing with differential equation and integration per se. So in one way or the other, you are basically doing one thing. So if you know differential equation, you study differential equation as ordinary differential equation and then also as partial differential equation. Then you also study about something called as dynamics, simple harmonic motion. What is it? It's the second order differential equation. Most of the equations of mechanics are governed by second order differential equation. So that's another way of doing it. But most of the student, they feel that all the topics are not interlinked, they are different, and this is the fallacy that you are committing all the while, and that is why you are just going by the market propaganda and substandard material and so on and so forth, which I don't want to really talk about. You are very well versed with everything, but there is something which is very coherent. I will be giving you a lot of examples. Suppose if I say fluid dynamics, most of the topics which you leave out, and then it is nothing but the interplay of a differential equation. At the end of the day, I am solving a differential equation when I am writing equation of continuity, that is dq by dt is equal to f net minus grad p by rho. That is nothing but a vector differential equation. I write down in three directions, whether if I write in Cartesian coordinate or some spherical coordinate. So the picture that comes into play is not physics per se, but it's the mathematics. So you are just missing out the huge chunk of the fact that this is something which is physics, so on and so forth. No, fluid dynamics is primarily the application of higher mathematics on fluid. So they are interested in the curl Laplacian and the divergence, so on and so forth, which you definitely study in vectors. You study in vectors f is equal to grad phi. Here you study q is equal to minus grad phi, and f is converted by the velocity vector field. So it is a myth that the syllabus is huge, humongous, and so on and so forth. If you try to see it from the various lenses, then you will be able to understand what I am speaking about. So if I talk of, say, rotation in two dimension, I can see it through the prism of linear algebra. I can also see it from the uses of what I would say in geometry, that I am basically rotating it, these y1, y2 to say z1, z2. So this is theta and this is alpha, so on and so forth. So a lot of things. I study the same thing in linear algebra. I study the same thing in geometry. I study the same thing in dynamics. That is, say, if I have this radial velocity and if I have this tangential velocity, they are mutually perpendicular. So basically, I am rotating it by 90 degree. So my this is the standard basis. It is rotated by 90 plus theta, right? So it is minus sine theta cos theta. So here I study in dynamics the same approach, in linear algebra the same thing. And so if you have that insight, if you develop that curiosity, then definitely it is not vast. But if you are someone who is very someone who is not just going by the hearsay and the rhetorical aspects, then definitely it's not for you. So you need to understand the rules of the game, and once you have understood, it is very easy for you to tackle these questions. So I just gave you an example, as I said. Okay, so paper 2, a lot of people say that it is humongous, but then it is not humongous. It is, if I talk of fluid dynamics and mechanics, In mechanics, what do I learn? I learn about Hamiltonian and Lagrangian. Okay, so here basically I am dealing in terms of Lagrangian. I am writing in terms of coordinate and velocity and time, and in Hamiltonian I am expressing in terms of position or momenta or time. So I play with basically differential calculus over here. And when I write down the Lagrange equation of motion, I'm basically dealing with the differential calculus. If I write in fluid dynamics, I just write this dq by dt is equal to, so what is this? This is not physics, but this is mathematics. If I introduce viscosity, this is your Navier-Stokes equation. So the point is very, very simple, that it is just a myth, it is just a hearsay that you hear about. No paper 1 and paper 2, they are very well connected, they are very well enmeshed, if you understand. If I ask you, say, integration a plus b cos theta, you study this, right? Don't you? You study this in calculus, where you put the value of cos theta in terms of tan half theta and tan square theta by 2. If I again do something in the contour integration, the same question, then this I convert it into polar form, that is e to the power I theta plus e to the power minus I theta by 2, and I put e to the power I theta is equal to z over the contour integration. I also know the answer, that it is 2 pi under root a square minus b square. So where are these? There are certain things they are segregating at one juncture to the another. You have to just understand the delicacies of the mathematics. If you really revel, if you are really well versed, and if you try to see it from the point of view of different modules. Okay, so when I particularly teach, when I'm teaching vectors, I'm always reminded of 3D and some sort of fluid dynamics and so on and so forth, which are interlinked. So if you start connecting a lot of dots, then you are in a better position to do in the examination. Otherwise, you are just mugging up the formula, having your own bunch of questions, and then you're not going to understand the nitty-gritty of the question, you're not going to understand the level of the examination, and you are left high and dry. So definitely beauty lies in the eyes of beholder, so does vulgarity. So if you feel that it is very big, mammoth, huge, but no, it is very elegant. The great thing about mathematics, it is love. Mathematics is about symmetry, patterns, and nature loves symmetry. Okay, so mathematics is about symmetry, and nature is also very symmetrical. So if you understand this fact for sure, then this is something is you're going to make the most of it. But if you take it as something which is rhetorical, or something which you need to cram without understanding, then definitely you are on the wrong path, and it is only for those who have that perspiration inside them, who have that imagination, and then you are able to do it, and the right guidance, of course. So most of the students, what they do, that they do whatever they have studied in MSc and PhD and so on and so forth. They are very much attuned to the books that they love, but at the end of the day, if you solve 15-20 years question organically and have that insight that you have developed, then more often than not you will be doing better. So one of the most important thing is that you don't have to look here and there for so many things. Okay, and what you should understand is that this is a static subject. Definitely the topics are very well articulated, the questions are repeated at times, and you can always find a pattern, you can always find a symmetry and analysis, and this is something which is going to reward you if you know how to play with it. If you do not know, then it's very difficult. Now the next question is that only engineers can crack maths optional, true or false? Well, it's partially true, because what the statistics say that the overwhelming majority of people are from engineering background, and why they're able to crack this examination with mathematics optional is the simple thing is that they just take the bull by the horn, and they do not have any biases that they are pure mathematician, or for that matter an applied mathematician. Just try to learn the syllabus. They have that knack of cracking the exam, because they just nitpick the important things and just leaving the other chunks. But definitely it is not the only engineers who rule the roost in the examination. A great number of people from mathematics background also do very good in this examination. But one of the fallacies and the foibles that they commit is the fact that they categorize themselves as something like, say, static and dynamics as physics portion and fluid dynamics and mechanics, and they never read it, they never understand the demand of the examination, they actually do not know the books, or they do not know how to approach it. So a larger majority of the maths background have failed because of this assumption, and this is something which is not in their interest. Secondly, what I have seen over the years, that even the bright students from the best of the universities in BSc and mathematics and MSc and so on and so forth, they flounder because they do not believe in themselves, and they feel that they never can master these topics, and it's too late when they come to us, and it's a very sorry state of affair for both the parties. So definitely it's not for engineers. It could be only for, also for those who are from BSc and MSc background, but they need to bolster their preparation by not being biased that they are good at this and good at that. Even I have seen, even if they are good at algebra and linear algebra, they are not able to do the fundamental questions. So they are just in a halo that they know things, but at the end of the day, it's the UPSC questions and your attempts in the examination that is really going to determine your future. And I firmly believe that your altitude would be determined by your attitude. So how you take it, whether you take the bull by a horn or you are just trying here and there, that is your question and your answer to be answered. So definitely non-engineering backgrounds, they have psychological fear, and their fear psychosis really make them in a situation that they ultimately start feeling that is difficult. But then it's not difficult if you have decided and if you go in the right direction. Now, thirdly, this question, very pertinent question: math optional risky, true or false? Well. Math optional is risky for those who have from history background, arts background, so on and so forth. But it's never risky for a person who has studied ardently mathematics, who has flair for mathematics, who have aptitude in mathematics. The only thing is that they have gone the wrong way, despite their knowledge, despite their acumen, despite their integrity and ingenuity to work hard, despite their past academics laurels, extraordinary academic achievements, still they flounder in this examination. The problem is not in you, but in the system that has been created. And I, for myself, have always tried that I do the justice to the people who come to me with whole heart and passion and commitment. But alas, quite a few people come with that faith and zeal, and those of who have come, they have got success, and this is just a blessing for both the parties. So most fundamental thing is that it is not risky in the first place. What make it riskier is your unscientific temperament. I say all to my student that success is like a science. If you have condition, you have the results. So in maths optional, if you are, it is very objective in the first place. Everybody will be saying this, but it's very difficult to have that tenacity, because most of the teachers or the student, they are not solving question from end to end. They're just beating out the bush. They do not know the depth of the subject, and which the student also copy that they will do it tomorrow and day after tomorrow, so on and so forth. So that is the biggest lacuna that I see, and it is very distressing for every one of us that that's the case. So your thinking make it so. If you have done it again and again, if you know how things work, then it really work in your favor. Else it is very difficult. It's very tumultuous time for you to really make a mark of it. So I really wonder why a student who has done BSc and MSc find, or for that matter engineering student, find it difficult. That means that they have not understood the whole idea of this subject, and maybe they are great at the subject, but they have not understood the need and the demand of the examination by UPSC for mathematics optional. So it is structured, it is objective. Why you fail, why you get less marks? Because you have faulty mechanism in the market, and for that you have to only find a way out, and it's completely in your hands and not in us. All we can do, if you come to us wholeheartedly, we can do our bid. But I feel that justice is giving everyone his due. So that can be only done when you come to the portals of success. Okay, so that's the thing. Now, most important problem is that 1 year is not enough for maths optional, true or false? Well, it depends on the fact that how long have you been preparing, what is your background, so on and so forth. Maths is not just merely completing the syllabus or reading hackneyed books and notes and so on and so forth, or just solving some 5 or 10 random pre-YQs and all of that. It is much beyond that. And for that, what you need is a rigorous understanding of the subject. It will take some time, and definitely 1 year is something which is neither very too much nor too little. But I feel that students feel that completing syllabus is merely referring to hackneyed books and notes and so on and so forth. But it's more than that, and that in some other sessions I will be dwelling upon that. Till then, thank you. If you like our content, please like, share, and subscribe. If you want to reach out to us, please do send us an email or reach out to our office at Old Rajendra Nagar 47 near Batra Medical, New Delhi. And it is very heartening for us to really help you if you are really wishing to. But if you are non-serious, if you are just dilly-dallying, if you are having something, then definitely that is not in our stride, neither in yours. So till then, see you. Goodbye.